Thank you for joining me today. My name is Kalkhof, and today I'm going to present to you the topic of my PhD, Democratizing Learning with Neural Cellular Automata. Let's start by looking at the map of access to healthcare worldwide. Something that we're seeing here is that particularly on the continent of Africa, but also in Southeast Asia, we are seeing a general lack of physicians. This is, of course, a problem for the access to healthcare. So what can we do to support the existing physicians in their daily work? One thing would be to deploy machine learning methods that can support them. The problem with current machine learning methods is that the research effort is mostly going towards parameter-heavy architectures, such as unit or transformer-based architectures, which require strong infrastructure. So instead, we need something that can run on minimal hardware, such as smartphones. And something that we have identified here is neural cellular automata as a lightweight and robust alternative. The idea behind NCAs is coming from cellular automata, where the most well-known example is the game of life. And the idea behind the game of life is that you have a locally interacting system with a set of predefined rules that is iterated over and over again. And now NCAs replace this hand-designed rule by a neural network. The problem is when we started working with NCAs, there were actually quite a few limitations that were stopping it from being used except for toy examples. The first one being high video RAM requirements, but also we had a rather difficult training because of the iterative process. And lastly, we would just get poor performance for these reasons. We solved this by introducing the MedNCA training pipeline. First at IPME and then a 3D variant at MICCAI last year. This has been awarded with the François Absman Prize and also the MICCAI Young Scientist Award. In terms of performance, we're actually looking at very similar accuracy like the state-of-the-art methods. So for example, the MedNCA with 8,000 parameters reaches around 90% dice on the hippocampus segmentation task, while a TransUnit reaches around, with 100 million parameters, reaches around the same performance. So we are very parameter efficient. One more very interesting thing about NCAs is that they use a random activation. This means if we run inference multiple times, we get slightly different outputs. And we used this phenomenon for a built-in quality control mechanism in our last year's MICCAI paper. But to truly democratize learning, we need to be able to use unlabeled data for training. And this is what we have done this year. And what we do is basically not only do we show that we can train, but also that we can do unsupervised fine-tuning directly on a smartphone based on the variants within NCAs. So as a community, we're now at a point where we have to make a decision. Do we want to keep pushing for these parameter-heavy methods? Or do we want to put our focus on these rather lightweight methods that we can really bring into everybody's hands to truly democratize learning? Thank you so much for your attention.